So during my previous video clip, we covered autoregressive settings. So I am going to cover or carry on covering the AR solution when we have autocorrelation in our time series. I think you also will be able to have one example that I think is going to help you to understand the basics of this problem of autocorrelation. Okay, let's go to my full desktop. So, right, so we stop here. The main idea of autoregressive AR models is that we model autocorrelation directly in regression model. And we model that using past observations as predictors. So here we have an example. Suppose that series have or exhibits an autocorrelation lag1 and 2. The way in which we are going to sort out these problems or this exhibit of autocorrelation in lag1 and lag2 is by adding the same variable as predictor of this yt variable, but with the lag of t minus 1 and t minus 2. I recall that this t minus 1 and t minus 2 refers to time. So this is time in time t, this is time t minus 1, this is time t minus 2. As you can see from this graph, we have made autoregressive models. In my opinion, autoregressive is just a complicated word to say that we are going to use lags in order to sort the problem of correlation between observations. In this case, this AR model is a AR model of order 2, and you can depict this in any paper or publication by saying that this is an AR2 model. Everybody will know that you are meaning that you are using this long equation just by saying AR2. So fitting and using AR models. So an AR model is equal or similar to a linear regression with lag series as predictors. So it's the same. So use the output to estimate coefficients, standard errors of estimates, etc. to forecast example, for example, an AR2 setting. So we perform a first step ahead forecast. Yes, so we have here ft plus 1. This is a one step ahead forecast. If we are going to do that, as you can see, ft plus 1, this is time t plus 1, is going to be modeled by time t and time t minus 1. So two previous lags. The two-step ahead forecast, which is t plus 2 time t plus 2, is going to be modeled by time t plus 1, the forecast, this previous forecast in t, time t plus 1, and also the time t. Yes, these letter b are the betas or the coefficients of these variables that we have in here. And we can go on and say that the three steps ahead forecast is going to be modeled. Three step ahead forecast is time t plus 3. Yes, is going to model by the forecast in time t plus 2 and the forecast in time t plus 1. So improving predictive accuracy is other of the topics that we want to use in order to modeling forecast errors using AR models. So the step 2 yes, is then to fit an AR1 model to the residuals. An AR1 model is using just a previous observation to model the series. And we can use an autoregressive integrated moving average. And we can set the autoregressive parameter to be equal to 1. That means that we are going to use just the previous observation in order to sort out the problem of autocorrelation, and we are going at the same time to use moving averages in order to smooth the time series. So we run the autocorrelation residuals of the residuals, yes, and the residuals after using the AR1 or ARIMA model, yes, is not showing any more signs of autocorrelation. So as you can see, we sorted out the problem by using a simple ARMA or ARIMA model. Yes, autoregressive meaning lags, and we integrate that with moving averages. So that is what is called ARIMA. So here we have the forecasted errors before AR. As you can see, we still have here in this place of the regression, we have some issues, yes, of autocorrelation. And here we have the forecasted errors after in AR11 is AR11 because, as you know, we think that this is too close to this dotted line, meaning that we need to sort out the problem of AR. And once we have we use the lag 11 in our series in order to like like solve the problem of autocorrelation. Here we have this autocorrelogram. Yes, this autocorrelogram is telling us that the problem has been sorted. So meaning that is possible that we are not going to have information in the errors. At least information coming from autocorrelation or um, like link or correlation between previous observations. So other possibility is forecasting with two-level models. Yes, so we can carry, actually you can use even more than two-level models, but I think if you understand what is level 1 and level 2 models, you will understand that you can carry on. So the level 1 is to model or raw data that or produce forecast and forecasting errors. I think at this very moment you are able to do that because you are able to find statistics that relates to the errors, especially for predictive accuracy. Yes, root mean square errors, mean errors, etc. Yes, and the level 2 is using the errors, yes, those errors after your forecast and fitting your estimations in order to um, uh, run a new regression applying an autoregressive or lags to these forecasted errors. So therefore you will have errors of the forecasted errors. Yes, errors of the errors, if you want. One example of that, I use this specification because I have some investments in the stock exchange. So if you want to forecast the stock exchange, you might want to know if you still have like valuable information in your errors. Because if that valuable information is in the errors, you will be probably missing accuracy. So what you can do then is to run a new regression using those forecasted errors. So that is why this level 2 is or produces errors of the forecasted errors. Okay, so we have here an exercise, putting everything together, getting improved forecasts. So we use a level 1 to forecast the next values of a series ft plus 1. Then we use an AR, a lag, to forecast next forecast error of the residual. Yes, so that is an ET plus 1. And then we combine the two to get an improved forecast of FT plus 1. So that is what you have in here, the first forecast and the forecast of the forecasted errors. Yes, so in general, what you are going to have here is a forecast of the errors. If you are able to forecast what are going to be the future errors, you will be able to add that to your previous forecast. That is the main idea, right? So obviously, if you are able to forecast the errors of the future, that would be fantastic, don't you? So doesn't it? Because if, for instance, you are in a competition and you are able to forecast what are going to be your errors, you will be able to correct your errors in advance. So that is the main idea of improving the forecast by trying to forecast the errors of the future. If you are not able to forecast the errors of the future, if that regression is non-significant, so therefore you have a series which do not have that autocorrelation. So we have here an example for the casting April 2003. Yes, and here we have the level 1 model. Yes, this was forecasted using model 5. Model 5 is a model with trend and seasonality. Yes, here we have the forecast for the observation in time 148. Yes, imagine that this is months. Yes, this is the intercepts 1933 minus a coefficient for the actual time, which is 148. And we also have a quadratic expression here for the time. As you can see, we have a riders. So I think this sounds to be the ridership, the Amtrak ridership dataset that you can find in our folder in Blackboard. After running this forecast, we have this expression, yes, we are able to run a level 2 forecast of the forecasted errors, assuming that the above model 5 is used. Yes, we have that the errors in the same period, 148, in time 148, have this equation. So this is the intercept, and this is the coefficient, and this is the lag 1 of the errors. Yes, as you can see from here, if we have this last error, we are going to be able to forecast as well what is going to not what is going to be the error for the period, the time 148. If you are able to do that, if these have significant results, so you will be able to add this to this previous forecast. Yes, and obviously if you are using a stock exchange or something like that, you will be able to improve your forecasts very much. Okay guys, so thank you for that. So I finished with this image that shows like the metaphor that we have used during this autocorrelation lecture, which is a relationship between two people, and how sometimes we are autocorrelated with our previous relationships. So thank you very much, and I will see you in my next video.